Hello everyone, welcome to the YouTube channel Math1089. We all know about the video lecture series 0 to Hero. In this video lecture series, we present each and every video from the scratch, in fact all the concept from the scratch and the respective illustrations to illustrate that particular concept. Then we solve regular problems or LOD 1 type problem, level of difficulty 1, then moderate level problems, LOD 2, and finally difficult questions, LOD 3. Together with, we consider the respective MCQs from that particular chapter, fill in the blanks type question and case study based question. In this video, we will consider compound angles, and this video lecture is for class 11 grade student. Support videos for JEE will also come in next few days. So let's start with the concept. First concept is the concept of compound angle. So what is compound angle means? Suppose two angles are given, A and B. We are taking two angles A and B. Now if we take the algebraic sum of this, that means A plus B, so this is a compound angle. Again, if we consider three angles, suppose A, B and C, then we can consider A plus B plus C. So these type of angles are known as compound angle. So basically compound angle is the algebraic sum of two or more angle. The next concept is the addition formula. The next concept is the addition formula for any two angles A and B, and let me call this as a theorem and let me write it as addition formula. Now here I will write four formula. The first one is A plus B is the angle, and what is the value of sine of A plus B? So sine of A plus B is equal to sine A cos B plus cos A sine B. Sine A cos B plus cos A sine B. Similarly, consider the angle A plus B. What is the value of cos of that angle? It is equal to cos A cos B minus sine A sine B. Here sine is extremely important. You can see that when the case of sine, the plus sign remains same as plus, but in case of cos, the plus sign changes to minus sign. Third one is tan of A plus B. It is tan of A plus B. The formula is tan A plus tan B by 1 minus tan A tan B. 1 minus tan A tan B. Now something I just want to say, but after writing the four formula we will discuss this. And finally cot of A plus B equal to cot A cot B minus 1 by cot A plus cot B. So these are the formula, but something need to discuss here. Now sine A is defined everywhere so is sin B. Similarly, cos A and cos B are also defined everywhere, so no restriction in the first two formula. But in the last two formula there are restrictions because tan A is not always defined. Similarly, tan B is not always defined, so is tan of A plus B. So here in this particular formula we need to take care of these three angles, that A, B and A plus B. These three angles should not be equal to an odd multiple of pi by 2. So that's why 2n plus 1 pi by 2, where n is an integer, Now the last formula, cot A, cot B and cot of A plus B must be defined, and for the same we need to impose certain restrictions, and the restriction is this, that angle A, angle B and angle A plus B should not be equal to an integral multiple of pi, that means not equal to n pi. What is n? N is an integer, so we can write n is an integer. So Z stands for integer, n is an integer. So in case of tan, these angles should not be an odd multiple of pi by 2, and in case of cot, the angles should not be a multiple of pi. Now it is the time for a proof of the formula discussed above. The first formula is sin of A plus B equal to sin A cos B plus cos A sin B. So consider this diagram here. Suppose OX is the revolving line. Suppose it rotates in anti-clockwise sense and the position is now OY such that angle XOY is equal to A in anti-clockwise rotation. Then again OY is rotated through anti-clockwise sense an angle of measure B. That means angle YOZ is now equal to B in anti-clockwise sense, so that angle XOZ equal to A plus B, that is also in anti-clockwise sense. Now our task is to find the value of sin A plus B. To find the value of sin A plus B, we need to do certain constructions. Let's do it. Consider any point P on OZ. From this point P, drop a perpendicular on the line OX, and suppose the perpendicular meets OX at the point S. Drop another perpendicular from P on OY. Suppose it meets OY at the point Q. From the point Q, drop another perpendicular on OX and assume that it meets OX at R. Also drop another perpendicular QT from the point Q on PS. So first we need to find the value of angle TPQ. What is the value of this angle TPQ? Now triangle TPQ is right angle with right angle at T. Triangle TPQ is right angle with right angle at T. Therefore, angle TPQ is 90 degree minus angle PQT, 90 degree minus PQT, but 90 degree minus PQT is same as angle TQO. Why TQO? Because angle PQO is equal to 90 degree. What is the value of angle PQO? That is also 90 degree. So what is the value of this much angle? This much angle is same as angle TPQ, but TQ is parallel, to OX. TQ straight line is parallel to OX straight line. So we can write TQO is same as QOR. QOR equal to A, because TQ is parallel to the line OR. Therefore, angle TPQ is equal to A. Now, what is the value of sine of A plus B? If we consider the triangle OPS, that is same as PS by OP. PS by OP. Which triangle we are considering? OPS, perpendicular by hypotenuse. Now PS is same as PT plus TS by OP. PT plus TS by OP, which is equal to PT by OP plus TS. We can write TS is same as QR by OP, because TS is same as QR. TS and QR are, that is same as PT by PQ into PQ by OP, and the second term is like QR by OQ into OQ by OP. Now what is the value of PQ, PT by PQ? PT by PQ. So definitely this is equal to cos of A, and PQ by OP, PQ by OP, that is equal to sine of B, plus QR by OQ, QR by OQ is equal to sine of A, and OQ by OP, OQ by OP, OQ by OP is equal to cos of B. If we arrange the terms, we can write it like sine A cos B. The second term will come first here, and the second term is cos A sine B. So it follows that sine of A plus B equal to sine A cos B plus cos A sine B. In this way, we can prove the other result for cos of A plus B, tan of A plus B, and cot of A plus B. Now here, one very important thing that we should always take care of. The formula for sine of A plus B is sine A cos B plus cos A sine B. Now student often made mistakes while applying this formula. And what is this wrong statement? They often write like sine of a plus b equal to sine of a plus sine of b. Of course, this is wrong. This is never true, but this is always true. For example, let's see that in few cases this formula won't hold. To verify, let us take a equal to 30 degree and b equal to 60 degree. Then what is the left hand side of this result? It is sine of a plus b, which is equal to sine of 30 degree plus 60 degree. One very important point here, that first we need to calculate the value of 30 degree plus 60 degree. So it is sine of 90 degree and the value of sine 90 degree is 1. On the other hand, right hand side is equal to sine of a plus b, sine a plus sine of b, that is equal to sine 30 plus sine 60. Sine 30 is equal to half, sine 60 is equal to root 3 by 2. So it is equal to 1 plus root 3 by 2, and definitely 1 plus root 3 by 2 is not equal to 1. So from here we can see that the left hand side value and the right hand side value are not matching. That means sine of a plus b is never ever equal to sine a plus sine b. In a similar way, we can write cos of a plus b is equal to cos a cos b minus sine a sine b. Here 2 points we need to consider. The first point is, when on the left side there is a plus sign, to the right you will find minus sign. That means the signs are opposite to each other. Moreover, sine of a plus b, like sine of a plus b is not equal to sine a plus sine b. In the same way, cos of a plus b is not equal to cos a plus cos b. We can take specific values and we can justify this. Similarly, tan of a plus b equal to tan a plus tan b whole divided by 1 minus tan a tan b, with certain restrictions that we should take the angles A, B and A plus B in such a way that they are always defined and it is not equal to tan A plus tan B, like the case of sine of A plus B and cos of A plus B. And finally, cot of A plus B is equal to cot A cot B minus 1 whole divided by cot A plus cot B, with certain restrictions that we should take the angles in such a way that all the angles like A, B and A plus B are all defined. So this is the way how we should take care of the formula and their applications correctly. One very interesting result, suppose we know the formula of sine of A plus B. We know this formula that sine of A plus B equal to sine A cos B plus cos A sine B. But suppose we do not know the formula for cos of A plus B. We do not know this formula. Then quickly we can derive this formula. Recall a formula sin theta equal to cos 90 minus theta. Sin theta equal to cos 90 minus theta. Let us apply this particular result to derive this result. So cos of a plus b is same as sin of 90 minus theta, and here theta is same as a plus b. So we can write it in this form: sin of pi by 2 minus a minus b, that is same as sin of pi by 2 minus a plus of minus b. Now everything over here is of the form sin of a plus b, where pi by 2 minus a is one angle and minus b is the other angle. So what is the formula? The formula is sin a, that means pi by 2 minus a, cos b, that is equal to cos of minus b, plus cos a, that is pi by 2 minus a, into sin b, that is sin of minus b here. So applying the result once again, sin 90 minus a is equal to cos a. Cos of minus b is cos b only. Then sin 90 minus theta, so it is sin theta, that is sin a, and sin of minus b, minus of sin b. So this plus into minus will give us a minus sign. We can write it in this form: cos a cos b minus sin a sin b. So eventually we can derive this formula for cos of a plus b from sin of a plus b, and in this way we can derive the other formulas also. Now let us consider the second theorem. So theorem 2. Theorem 2 is commonly known as subtraction formula. So here we will consider angles like a minus b. So these are subtraction formulas. So the first formula is sin of a minus b. The second formula, cos of a minus b. The third formula, tan of a minus b. And the fourth formula, cot of a minus b. Now the first formula is this: sin of a minus b means sin a cos b, then minus cos a sin b. Cos of a minus b is cos a cos b plus sin a sin b. Tan of a minus b is tan a minus tan b by 1 plus tan a tan b. And cot of a minus b is cot a cot b minus 1 divided by cot b minus cot a. Now few very important things need to understand. You need to remember that in case of sine, left hand side minus, right hand side minus, no issues. But in case of cos, if left hand side minus, then right hand side become plus. So always opposite. In case of tan, this formula is valid only when the angle A, angle B and angle A minus B are not an odd multiple of pi by 2. So should not be equal to 2n plus 1 pi by 2, where n is an integer. What is n? N is an integer. Similarly, in case of cot, AB and A minus B should not be equal to a multiple of pi, where n is an integer. It should not be a multiple of pi. Moreover, there is one point that we should keep in mind. In case of cot, B will come first, cot B minus cot A, and it is not equal to like cot A minus cot B. If anybody write this, this will become a wrong statement. So cot B minus cot A and not cot A minus cot B. So this is about the various formula that we need to remember. We now consider 4 regular questions. Definitely these questions are a direct application of the formulas studied so far. First question is, find the value of sine 75 degree. Find the value of sine 75 degree. We have taken one question from sine, one from cos, one from tan, and one from cot. Now the first question, sine 75 degree. Definitely we can write 75 degree in this form, sine of 45 degree plus 30 degree. So definitely this is in the form of A plus B, sine of A plus B, and what is the formula? Sine A cos B plus cos A sine B. So let us write it, sine A cos B, so sine 45 cos 30 plus cos 45 sine 30. If we substitute the values, then this is equal to sine 45 is 1 by root 2, cos 30 is root 3 by 2, cos 45 is 1 by root 2, and sine 30 is 1 by 2. That is equal to root 3 plus 1 by 2 root 2. Root 3 plus 1 by 2 root 2, and after rationalization, root 2 into root 3 plus 1 by 4, which is equal to root 6 plus root 2 by 4. Now any question you need to ask here, but if you cannot, I have few questions for you. At least one question I definitely have. Proceeding for the next question, that is cos 135 degree, we can write it like this, cos of 90 degree plus 45 degree. What is the formula for cos of A plus B? The formula is cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B. Now here cos 90 is 0, cos 45 is 1 by root 2, so the first term is 0. And what about the second term? Second term is sin 90 1 and sin 45 1 by root 2. So if we rationalize it, root 2 by 2 is the answer. Do you have a question to ask over here? If yes, very good. If no, I have something to ask you. 10105, third question. we can write as before 60 plus 45, that is tan of a plus b, with a equal to 60, b equal to 45. Formula is tan a plus tan b by 1 minus tan a tan b. 1 minus tan a tan b. Let's apply the various values of the angle. Tan 60 is root 3, tan 45 1, so root 3 plus 1 by 1 minus root 3. So for rationalization, we can multiply both numerator and denominator by the factor 1 plus root 3. So let us multiply it by 1 minus root 3. So this will become minus 2, and the upper one root 3 plus 1 whole square. This is equal to 4 plus 2 root 3 by minus 2. After simplification, 2 plus root 3 with a negative sign at the very beginning. Any question to ask? But at least one question from my side is waiting. Cot 120 degree. Cot 120 degree, we can write it like this: cot 90 degree plus 30 degree. So cot of a plus b, what is the formula of cot of a plus b? Cot a cot b minus 1, cot a cot b minus 1 by cot a plus cot b. So cot 90 plus cot 30, that is equal to cot 90 is 0, so minus 1 in the numerator, and in the denominator 1 by root 3, that is equal to minus root 3 is the answer. Now one question here also from my side. Till now, if you can able to recognize the question, very good. If not, then a big question for you. Now in the first question, when 75 degree is there, and in place of 75 degree we have taken 45 plus 30. Why in place of 75 we are taking 45 plus 30? I can give you few other choices also. For example, 50 plus 25, their sum is also equal to 75 degree. Then it can be like 65 degree and 10 degree also, and in fact various other choices. My question is this: why we have not taken the other one but taken 45 and 30 combination, 45 and 30 combination, and we are not taking 50 and 25? This is the question. Now for an answer, just recall that in class 10 mathematics, from your understanding, you all know the various values of the trigonometric functions of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. And we do not know what is the sine value of 50 degree. That means sine 50 degree we do not know, sine 25 degree we do not know, or cos 25 degree we do not know. But what is the formula for sine of a plus b? Instead of 45 degree, if I take like 50 degree plus 25 degree and that too a sine before it, then sine 50 cos 25 plus cos 50 sine 25. How do I write the answer? It is not possible. So that's why if you just want to ask me that question, that why 45 and 30 degree combination, so here is the answer. The same answer goes to 135 degree also, 90 degree and 45 degree. There are few other combinations also like 60 degree and 75 degree. Once again, that is also possible, but that is become too difficult. Similarly, for other angles also the same rule applies. 120 also the same rule applies. So we will take that angles whose various trigonometric values are known to us only. Consider these two questions. The first question is sine of minus 150 degree. What is the value of sine minus 150 degree? Recall that sine of minus theta is equal to minus sine theta. Sine of minus theta equal to minus sine theta. That means we can write like sine of minus theta equal to minus of sine theta. So this is same as minus sine 150 degree, and 150 is equal to 90 and 60. 90 and 60. So minus sine, then apply the formula sin A cos B plus cos A sin B will give us the value which is equal to minus root 3 by 2, because cos 90 is 0. What is the value of cos 90? Cos 90 is equal to 0. And what is the value of sin 90? Sin 90 is equal to 1. Now in the second question, cos of pi by 12. Now student, I will argue you not to change it to degree. But if you change it to degree, there is no harm definitely. But I will suggest you not to change it into degrees. Do it through radian mode only. So cos of pi by 12, and recall that pi by 12 is nothing but 15 degree. Pi by 12 is equal to 15 degree. So we can take like 3 pi by 12 minus 2 pi by 12. So that is same as cos of 3 pi by 12 minus 2 pi by 12. Now what is the value of formula for cos of A minus B? It's cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B. Now sine of 3 pi by 12 is same as cos pi by 4, whose value is 1 by root 2, and cos 2 pi by 6 is 2 pi by 12 is equal to cos pi by 6, whose value is root 3 by 2. Second one, sin pi by 3 pi by 12 is 1 by root 2 into sin pi by 6 is equal to 1 by 2. That is same as root 3 plus 1 by 2 root 2, and after doing a little bit of simplification, we can write it like root 6 plus root 2 by 4. So this is the answer, or this is the value for cos of pi by 12. We now consider two more questions. First question, that is question number 7, we need to prove that tan of pi by 4 plus theta into tan of pi by 4 minus theta, their product is equal to 1. So let us start with the left hand side. And here we will consider the first term only. What is the first term? Tan of pi by 4 plus theta. That means tan of A plus B. If we apply the formula, then what we can write? Tan of A plus tan of B by 1 minus tan A tan B. That means tan pi by 4 plus tan theta by 1 minus tan pi by 4 into tan theta. Value of tan pi by 4 is 1. Value of tan theta will remain same and it is equal to 1 minus tan theta. Now when we will consider the second term, that is tan of pi by 4 minus theta, so here we will write minus sign. And what is the formula for tan of pi by 4 minus theta? Tan A minus tan B by 1 minus 1 plus tan A tan B. So here we will write minus and here we will write plus. That means here minus and here plus. So from this it follows that the left hand side is equal to the first term 1 plus tan theta by 1 minus tan theta, and the second term is 1 minus tan theta by 1 plus tan theta, and essentially they cancel each other. Therefore equal to 1, and that is the value of right hand side. So in this type of question, how to start? The main component of this question is simply to apply the formula for tan of A plus B. So tan of A plus B, the result is tan A plus tan B by 1 minus tan A tan B. And for the second one, tan of A minus B, the result is tan A minus tan B by 1 plus tan A tan B. Now, to solve this question, let us say that we are given two different types of angle. One is 50 degree, another one is 20 degree. If we add these two angles, so 50 plus 20 is 70 degree. If we subtract these two angles, so 50 minus 20 equal to 30 degree. Now 70 degree is not any standard angle. So 50 plus 20 equal to 70 degree. This relation will not help. So the only relation that will help us is 50 minus 20 equal to 30 degree. That is the first observation. Second observation is this: left hand side contains cos term and sine term both, but right side contains only cosine term, right side only cos term. So anyway, we need to apply the formula of cos A plus B or cos A minus B. So any of these two, cos A plus B or cos A minus B. So if we start taking like cos of 50 minus 30 is equal to 20 degree. So what we will do? Let's start with left hand side. That is equal to root 3 into cos 50 degree plus sine 50 degree. Let us take a common of half. If I just want to take a common of half, then I need to multiply it by 2, because 2 into half will give us 1 only, and the rest of the term root 3 cos 50 plus sine 50. Fine. In the next step, half will enter inside. That means to the right we will find 2, and inside root 3 by 2 cos 50, then half sine 50. Then root 3 by 2 is same as cos of 30 degree, cos 50 is there, half means sine of 30 degree and sine 50 is there. So cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B. Formula is cos of A minus B. Cos of 50 minus 30 degree. Any question you want to ask me here? If yes, fine. If not, then I will ask you after the solution. That is equal to 2 cos 20 degree, which is equal to right hand side. That means this statement is proved. Now coming back, 2 cos 50 minus 30. Somebody may ask you, if I write it like 30 minus 50, then what will going to happen? Nothing will happen, because in that case cos of minus 20 will come, and we know that cos of minus theta is cos theta itself. Cos of minus 20 is equal to cos 20 itself. So no difference whether you will write it like cos 50 minus 30 or cos 30 minus 50. The next question is prove that sin 105 degree plus cos 105 degree equal to 1 by root 2. It's a direct application to the formula. So let's take left hand side, that is equal to sin 105 degree plus cos 105 degree. We can write it like 60 plus 45. Second one also 60 plus 45. Apply the formula. Sin A cos B plus cos A sin B for the first one, and for the second one cos A cos B minus sin A sin B. That is equal to root 3 by 2 into 1 by root 2 plus 1 by 2 into 1 by root 2, and the second one 1 by 2 into 1 by root 2 minus root 3 by 2 into 1 by root 2 equal to root 3 plus 1 by 2 root 2 plus 1 minus root 3 by 2 root 2. If we add them, 2 by 2 root 2, which is equal to 1 by root 2, and that is equal to right hand side. It's a direct application of the formula sin A plus B and cos of A plus B. So left hand side equal to right hand side, and we are done. But we can solve it in a different way also. Let's see what is the alternative approach by which we can solve it. Now let's start with, since we can find 1 by root 2 in the right hand side, keeping that note, how we can write the left hand side? The left hand side is sin 105 plus cos 105. Okay, that means let us write root 2 into 1 by root 2 as before, and sin 105 plus cos 105 as usual. So root 2 outside, 1 by root 2 sin 105, 1 by root 2 cos 105. that is equal to root 2 into sine 45 sine 105 plus cos 45 cos 105. Now it's the time to rearrange the term. First we will write this term and then we will write this term, that is equal to root 2 into cos 105 cos 45 degree plus sine 105 sine 45 degree. So cos A cos B plus sine A sine B. Formula is cos of A minus B, that is 105 minus 45 equal to root 2 cos 60 degree. What is the value of cos 60? It is half. After cancellation we get 1 by root 2 and that is equal to right hand side. Hence left hand side equal to right hand side as before, and we are done. Now the next question is prove that cot 2a cot a minus cot 3a cot 2a minus cot 3a cot a equal to 1. There are three different types of angles present here. One is A, 2a and 3a, and there is a very simple relation between them, that 3a equal to 2a plus a. Moreover, everywhere we can see cot only. That means we need to apply cot of a plus b or cot of a minus b. So 3a equal to 2a plus a, if we apply cot here, then what I can write? Cot of 3a equal to cot of 2a plus a. It is like cot of x plus y formula. Cot a cot b, that means cot 2a cot a minus 1 by cot a plus cot b, that is cot of 2a plus cot a cot b minus 1 by cot a plus cot b, and this is equal to cot 3a. If any confusion is there, we can write it like by 1. And now what we will apply? Cross multiplication. So multiply the terms like cot 3a into cot 2a plus cot a, which is equal to cot 2a cot a minus 1. After expanding, cot 3a cot 2a plus cot 3a cot a equal to cot 2a cot a minus 1. Now what we have to do? Simply transfer this one to the left side and this term to the right side, this term to the right side. So finally we can write cot 2a cot a, this term, minus cot 3a cot a, this term, minus cot 3a cot 2a, this term, equal to 1, this term, and hence the result is proved. Now this is the next question where we need to determine the sign of the expression sine 100 degree plus cos 100 degree. So sine 100 degree and cos 100 degree. Here we can see that sine and cos both are present, and the angle that we are considering is 100 degree. So 100 degree is the angle. That means sine 100 degree plus cos 100 degree. If we write it like this, 1 by root 2 into root 2, the value is 1, and sine 100 degree plus cos 100 degree inside the bracket. So root 2 into 1 by root 2 sine 100 degree plus 1 by root 2 cos 100 degree. Now what is the value of 1 by root 2? We can write it like this: 1 by root 2 sine 100 and cos 45. The second one, 1 by root 2, so cos 100 sine 45 degree. We are writing it in this way so that the expression becomes in the form of sine a plus b. Sine a plus b, that is equal to sine of 100 plus 45 equal to 2 sine 145 degree. Now 145 degree can be written in this form: 180 minus 35 degree, 180 minus 35 degree, and sine 180 minus theta is equal to sine theta, because the angle is in the second quadrant. So this expression is same as root 2 sine 35. So root 2 sine 35, sine 35 degree is an angle in the first quadrant. 35 degree is an angle in the first quadrant, and sine of it is always positive. As a result, sine 35 degree is always positive, always greater than 0. And root 2 is a positive quantity, so if we multiply root 2 with sine 35 degree, that will also be positive. As a result, we can write root 2 sine 35 degree is greater than 0. So determine the sign of this. What is the sign of this? Sine 100 degree plus cos 100 degree, it is always greater than 0. That means it is always positive. The next question is, given that x equal to tan 15 degree, and to prove that x square plus 2 root 3x minus 1 equal to 0. So x equal to tan 15 degree, and to prove x square plus 2 root 3x minus 1 equal to 0. So once again, this is a direct calculation formula. First we need to find the value of x. That is very important. And what is x? X is tan 15 degree. After finding the value of x, we need to substitute the value in the expression of the left hand side. Substitute the value in the left hand side. So x equal to tan 15 degree, same as tan 45 minus 30. Formula for tan a minus b: tan a minus tan b by 1 plus tan a tan b. Apply the result, like tan 45 1 and tan 30 is 1 by root 3. This gives x equal to root 3 minus 1 by root 3 plus 1. Let us multiply both numerator and denominator by the rationalizing factor root 3 minus 1. So multiply it by root 3 minus 1. That gives us root 3 minus 1 whole square by 2. It is equal to 4 minus 2 root 3 by 2. After cancellation, 2 minus root 3. So eventually the value of x is 2 minus root 3. The value of x is equal to 2 minus root 3. Now x is equal to 2 minus root 3. And what is the left hand side here? X square plus 2 root 3x minus 1. We need to prove that the right hand side is equal to 0. So x square means 2 minus root 3 whole square plus 2 root 3 into 2 minus root 3 minus 1 equal to 4 minus 4 root 3 plus 3. This is the term after expansion of the square term plus 4 root 3 minus 6 minus 1, that is equal to 7 minus 4 root 3 plus 4 root 3 minus 6 minus 1. Now minus 4 root 3 plus root 3 out, plus 7 and minus 6 minus 1 all together gives us 0. That is equal to right hand side, and hence it is proved.